Welcome back to Basic Mathematics. In this video, we're going to be looking at solving percent problems. Remember from last time that percent notation allows us to give a more convenient way of talking about fractional values. In this video, we're going to be looking at how we construct percents and how we work percents into the everyday English language in order to describe the problems that we want to solve in mathematics. So without further ado, let me get my head out of the way and let's talk about that. That's not my blue pen. As we've mentioned before, the important thing to keep in mind with percents is that even though a percent looks like a number, it really is not a number. It's something different. And so when we are talking about percents, we always have to use this percent of structure. And when we're talking about a situation around a percent, we're going to take a percent of the whole, the entirety of whatever situation we're looking at, and that will give us the part, the portion of the whole that we care about for whatever application we're dealing with. Translating, you have two options. Some people really find it straightforward to work with percents as proportions. And the nice thing about working with percents as proportions is it allows you to convert your percent into a fraction, percent over 100. And then you can use all the problem-solving tools of proportions that we've talked about previously. The other option is to rewrite the percent problem as an equation. And in order to do that, we can use two simple facts. The word is almost always translates to an equal sign, or really any verb translates to an equal sign in mathematical notation. And the word of almost always translates to multiplication. The trick here is that the percent has to be converted to a decimal value. And you get the equation either part equals percent times whole or percent times whole equals part. Last time we were looking at that percent times whole, percent of notation, and going in that direction is fairly straightforward. The tricks we're going to be looking at here today are moving in other directions. So to explain, if the problem asks something like, what is 35% of 80? To write this as a proportion, we would get 35 over 100 equals what? Well, I have no idea what. That's what variables exist for. Call that x over 80. To write it as an equation, again, I have no idea what, so call it x. Is means equal sign. 35% as a decimal is 0.35. Of means multiply, and then 80. Personally, I find the percent equation to be a little bit easier, but you are not me. You may find that setting it up as a proportion makes more sense to you. Here, 35% of 80, 0.35 times 80, is a fairly straightforward calculation. Eight times 5 is 40. 8 times 3 is 24. Plus 4 is 28. Move the decimal point over 2 places. You get x equals 28. On the proportion side of things, you would multiply 35 times 80 and get 2,800. You'd get 100 times x, and you'd divide both sides of the equation by 100 to get that x is 28. The proportion has the nice advantage of avoiding working with decimal values. If the thing that's unknown is not the part, then we can use algebra skills to work out what happens there. %40 of what number becomes 16? Setting this up as a proportion, it's always percent of whole, so 40%, 40 over 100. And then the whole value is unknown, we'll call that x. This phrase uses become instead of is, but again, any verb can fill in that spot. The part is on the other side of the verb, in this case, 16. Setting it up as an equation, 40% as a decimal is 0.40. Of means multiply. What number? I have no idea. We'll call it x. Becomes, any verb turns into an equal sign, and then 16. Solving the proportion works basically the same. Cross product test, 40 times x, 100 times 16 is 1,600, and then get x by itself by dividing by 40. Kind of conveniently, 1,600 divided by 40 is 40. So that works out nicely. In the percent equation camp, you get 16 divided by 0.4, which is the same thing as 160 divided by 4. And you get that x is 40. The one place where the proportion notation can tend to be a little bit easier to deal with is when the unknown is the percent. $25 is what percent of 125? Setting this up as a proportion, the percent is unknown, but it's going to go over 100. The part, the thing that's on one side of the verb, 25, the thing that comes after the word of is the whole, in this case, 125. Setting this up as a percent equation, 25 is means equal sign. What percent? I don't know. We'll call it x. Of means multiply, and then 125. Solving the proportion, we use the cross product test yet again. 125 times x is equal to 25 times 100, or 2,500, which means that x is 2,500 divided by 125. And you can reduce this one by noticing that top and bottom are both divisible by 5. And still both divisible by 5. and still both divisible by 5. X is 20%. On the equation end of things, to get x by itself, we're going to divide both sides of the equation by 125. And you can again notice that top and bottom are divisible by 5 and are again. And notice here that we have a fractional value 1/5, or if you prefer, 5 goes into 1, well, it doesn't, but 5 goes into 10 twice, giving us 0.2. The one drawback, and the one reason I might suggest against using the percent equation version, is that when you solve a percent equation and the problem asks what percent, you need to remember at the end that what you have is a decimal or perhaps fractional value, and you have to convert from a decimal to a percent. When you solve using a proportion, that is something you can avoid. So there are pros and cons to both methods. There is no right or wrong answer. It's just a question of which one works best for you. And there's not really anything to it except to play around with that. So take a look at the practice problems asking you to solve percent problems like this. Your choice whether you want to use percent equation or percent as proportion. One thing that I will let you know setting up in the homework, the first third of the problem set is going to be basic percent skills that we've talked about previously with some slightly crunchier numbers. The middle third is going to be percent problems set up as equations, and the last third is going to be percent problems set up as proportions. Depending on which of the two you want to use, you may want to go from the beginning straight through, or you may want to skip to the end when you start hitting the percent problems, so that the help me solve this button will give you the proportion setup instead. Either way, whatever you want to do is perfectly fine. And I'll see you in the next video when we start using this.